Hello students, here we will start the paper 2 of semester 2 and the name is what? Graph theory. Graph theory. Graph theory is actually related to many branches of mathematics. It is widely applied in subjects like computer technology, communication science, electrical engineering, physics, architecture, operation research, economics, sociology, genetics, etc. In the earlier stages, it was called slum topology. It is what also called as slum topology. Okay. Euler, Cayley, Sir William Hamilton, Levin and Kirchhoff laid foundation to the graph theory. Graph theory was born in 1736 with Euler's paper on conic bridge problem. As we know, the seven bridge problem. The Konigsberg bridge problem is the best known example in graph theory. It was a long pending problem. Till today, it is unsolved problem. Euler solved this problem by means of a graph. Euler became a father of graph theory. Kirchhoff, Cayley, Mobius, Hamilton, and De Morgans have laid strong foundation and contributed much to the development of the subject. In this chapter, the basic concepts and the terms of graph theory has been introduced. So, we will start with chapter 1, in which we will see some basic things. Chapter 1 is an introduction to graph. An introduction to graph. So, let's see the definition of graph first. Definition of graph says, let V is a non-empty set and E be a family of unordered pairs of the elements of set V, then the ordered pair V with E means ordered pair of these two sets, a non-empty set and a set of family of unordered pairs, is called a graph. Is called a graph and is denoted by G. That is, G equal to what? This order pair V with E is a graph. The set V is known as vertex set of G. Each element in V is known as a point or vertex or node, or what? Node. The set E is known as Set E is known as edge set of G. Each element in E is known as edge of a graph G. Edge of a graph G. Generally, V is small letters. We are using V1, V2, V3 and so on. Small alphabets we can use. Okay. And E can be written. E is denoted by here also E1, E2, E3 and so on as such. Okay. These are the general way. If E is Vi, Vg belongs to E. Suppose E is this, Vi, Vg belongs to E. Then we say that Vi, actually it will be an order pair. Yeah. Then we say that Vi and Vj are the end vertices. Of an edge E. Means here somewhere Vi and somewhere Vj is there, and the edge between them is what? This E. We will see it further. Okay. Now this can be said as such the vertices of edge E, or another way, Vi and Vj are adjacent vertices of an edge E, or edge E is incident on the vertices Vi, Vj. Okay. Generally graphs are represented by diagram. Generally graphs are represented by diagram known as diagrammatic representation. Vertices are represented by points or small circles. As such. Okay. While edges are represented by line segment or the arcs Let's see an example of graph. If V is V1, V2, V3 and so on up to, or let's write V4, V5, this much only, okay. And suppose set E has E1, it is V1, V2, E2, it is E2 will be V2, V3, E3 will be V3, V1 and E4 will be V3, V4 suppose. Okay, if these are the things, then G, the graph between this V and E is a graph. How does we can show it? It will be V1, suppose vertex is denoted by either points or small circles, so let me use small circles. Suppose here V1, V2, V3, V4, V5. Suppose V1, V2, V3, V4 and V5. Suppose now E1 is between V1 and V2, so there is a line segment between them. This is what? E1. E2 is between V2 and V3, so there will be a line segment between them. E2. E3 will be between V3 and V1, so it will be E3, and E4 will be between these one. Okay, this is a side. Fine. Now let's see some definitions from this. So the definitions are some definitions. Now, before going towards the definitions, let me give one note also. The elements of E means edge set can be repeated. Elements of edge set can be repeated. Now some definitions. So let me take first definition. Self loop. Self loop. What does this say is the edge E between U and V, suppose it belongs to edge set E. E is known as self loop, is known as self loop if U equal to V. If these are same, means it is edge between the same vertex, then it will be a self loop. As it will be as such E. Here U equal to what? V. Another definition, parallel edges. Parallel edges. Let's see two edges E1 UI VI suppose, and E2 it is UJ VJ. It is between UJ VJ are said to be parallel if this UI is equal to UJ or VJ, any one of them, and if UI equal to UJ, then VI must equal to VJ, or if UI equal to VJ, then VI must equal to what? UJ, and VI equal to VJ or what? UJ. These are the possibilities here. That is, two edges having same end vertices. Same end vertices. Or we can write it as, suppose UI is equal to UJ and another vertex VI equal to VJ. Then suppose this is edge E1 and this is another edge E2 is there. This is what? A parallel edges. Next one. Next definition is of adjacent edges. Two edges are said to be adjacent if they have one vertex in common. That is, two edges are adjacent if they are incident on the common vertex. Incident on the common vertex. As suppose U, V and W are three vertices. Okay, there is edge between these. This one, suppose it is E1, this is E2. This V is common between E1 and E2. So E1 and E2 are what? Adjacent. So E1 and E2 are adjacent as V is common to both. Okay. The next definition is of degree of vertex. Degree of vertex. If V is the vertex of a graph G, if V is the vertex of the graph G, then degree of V is defined as the number of edges number of edges incident at V. At V. It is denoted by degree of V or simply D of V also. Okay. Now, next definition is of even vertex. The vertex V is even if degree of vertex is even. Next, odd vertex. You can easily judge this one. If degree is odd, then the vertex will be odd. The vertex V is odd if degree of vertex is odd. Okay. Then next one, pendant vertex. Pendant vertex. The vertex V is pendant if degree is 1. If degree is 1, then it will be pendant vertex. Then next, isolated vertex. The vertex V is isolated if its degree is 0. Look at it carefully. This is very important thing. Degree of vertex means how many edges are incident on that vertex. Okay. Even vertex if degree is even. Odd if degree is odd. Pendant if degree is 1. Isolated if degree is 0. Now let's take one small example on this one. Example, find the number of vertices, the number of edges and the degree of each. Vertex in graph, in a graph given. Now what was the graph? The graph is suppose 4 vertices are here. A, B, C, D, E, F, suppose G, H and I. Okay. Then how does the edges are there? There is edge between these one. Suppose this is our graph. Also the question is that identify all isolated and pendant vertices. Isolated and pendant vertices. So let us see the answer. How does we will solve it? Now look at find number of vertices. So count them. A, B, C, D, E, F, G, H, I. Means 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of vertices are how many? 9. Now number of edges. So let's calculate them. So 1, 2, 3, 4, 5, 6. This is 7. Okay. This is 8 between them. 9, 10, 11. This is 12. How many edges are there? Edges are 12 are here. Fine. And anyone left? Check it. 1. No. So 12. Fine. Now degree of each one. Now let's find degree of A. Let me write all and I will explain it so that we can easily write them. Degree of B. Degree of C. Degree of what? D. Degree of E. Degree of F. Degree of G. Degree of H and degree of I. Okay. Now let's see on A how many edges are go from A. So look at this is one edge, this is another edge. So degree of edge is how much? 2. On B look at this 1 and 2. So degree of B is how much? Also 2. What about C? Look at here one edge, here one edge. So degree of C is also what? 2. Okay. Fine. Now what about D? For D it is not connected to anyone. So degree of D is what? 0. So as its degree is 0, so it is what? Isolated. It is isolated vertex. What about degree of E? Look at this E. So this is one self loop is there. This is another edge and this is one more. So how many edges are there? 3. Degree of E is how much? 3. Okay. Then degree of F. Look at F. Only one edge will goes here. So the degree of F is 1. So it is which it will be pendant vertex. It is pendant. Degree of G. Look at G. This is 1, 2, 3, 4. 4. Degree of G is how much? 4. Degree of H. Look at 1, 2, 3, 4 and what? 5. Degree of H is what? 5. Degree of I. 1, 2, 3, 4. 4 edges are incident on it. So 4. As such we can determine the degrees and vertices, edges. Edges can be calculated as these one will be added and do the half of them, because we have been calculated at A also and at I also the same age. Yeah. So this is 4 plus 5, 9 plus 4, 13, 14, 15, 16, 17 and 17, 19, 20, 21. It will be, is it 12? 1, 2, 3, 4. We haven't calculated any one twice. 5, 6, 7, 8, 9, 10, 11, 12. It's okay. Fine. Okay. So this is about the introductory part or some definitions. In next video, we will see the directed graph and the definitions related to it. Also, the handshaking lemma. It is about the degree and the number of edges. Thank you.